All right, so here's assignment 6.4, logarithmic functions, and we jumping right in. The first two questions ask about the function's properties in general. So over here on the right side, I have the function just graph for visual aid. You can see the graph of the function. You remember that it is the inverse, that logs are the inverse of exponential functions. So the domain this time will go from 0 to infinity. We see that it has this vertical asymptote at the y-axis, so it's going from 0 and it's going out towards positive infinity. Likewise, the range is going from negative infinity to positive infinity. So for answer choice for number 1, our answer choice is going to be x is greater than 0, or if you have it in interval notation, it's going from 0 to positive infinity. Number 2 says decide whether the following statement is true or false. It says that for the graph of your log functions is going to have an x-intercept equal to 1 and no y-intercept. And we can see for our general log function with no transformations, remember the y-axis is a vertical asymptote, so it doesn't cross the y-axis, meaning it has no y-intercepts. And we see this point right here at 1 and 0. Our x-intercept is indeed equal to 1. So choose the correct answer choice below. This one is actually true. Number 3 says determine the domain of the log function log base 4 of x plus 5. So now for our log functions, in order for our domain to be valid, the argument of the log function has to be greater than 0. So we have to take the x plus 5 and set that greater than 0. And remember that it is not equal to because it can't be negative or 0. So we have x plus 5 is greater than 0. We subtract 5 on both sides. We get x is greater than negative 5, or for the interval is going to be from negative 5 to positive infinity. So we see that it's our third answer choice here. For number 4, this is just saying change the exponential statement to an equivalent statement involving a logarithm. So all we're doing here is going from exponential form to logarithmic form. Remember that logs are BAE, B-A-E. You have your base, you have your argument, you have your exponent, or you have your base, you have your answer, and your exponent. So when you write it as an exponential, you know the base is the base, your exponent is the exponent, and your argument is your answer. So B-E equals A. So going from 16 equals 4 squared, we rewrite that as a logarithm. We have log base 4 of 16 equals 2. And it's just that simple transformation. All right, so for 6 through 11, I figured we might as well just work a few of these in Math Excel. It says, once again, change the exponential statement to an equivalent statement using logarithms. So remember, for logs, it's going to be base, it's going to be log B-A-E or log bay. So we just want to rewrite it as a logarithmic statement. So we have log, the base in our problem is 6. The answer in this problem is 1.8, or the argument now when we write it as a logarithmic expression, and that equals our exponent, which is x. All right, next up it says change the exponential statement to an equivalent statement involving a logarithm. Once again, we're going to go from exponential form to logarithmic form. So this time we have log and our base is e of 2 equals x again. This time we're going from a logarithmic statement to an exponential statement. So we have the base being 2, the exponent is 4, and our answer is going to be 16. So we have log, we're going to exponential. So we have 2 raised to the 4th power equals 16. Number 9, our base is a raised to the 9th power equals 5. Number 10, our base is 9 Our exponent is x, and the value is 81. So now it's written as a natural logarithm. Just remember that when it says the natural log, is taking the log of the natural number, which is e. So in this case, when we see ln, that automatically indicates that our base is e. And then from there, everything else is the same. It's raised to the x power. And it equals our answer or our argument, which is 10. And now we're going back. All right, so starting with number 12, they have us evaluating log expressions without using a calculator. So they give us the log expression and they want to know what it equals. What I like to do is I like to take them after they have it equal to blank and they're asking us. I just use an x so that we can turn it into a full-on equation and then we can just solve the equation. So it's telling us log base 6 of 1 equals x. So we can rewrite it as an exponential equation that will be easily solvable. So we have 6 raised to the x power is equal to 1. Remember that anything raised to the 0 power will be equal to 1. So we can always substitute 1 for some exponential expression that's raised to the 0 power. So we can have the same basis. We have 6 raised to the x equals 6 raised to the 0 power. The bases are the same, so we can drop them and we see we have x equals 0. So log base 6 of 1 equals 0. Number 13 is a very similar problem, or we're going to work it the same way. We have log base 5 of 125, and we're trying to figure out what that equals. We set it equal to x, and then we solve it. After changing it to an exponential equation, we see we have 5 raised to the x equals 125. We can use 5 as our base, so that means 125 equals 5 to the third power. So we substitute 5 to the third power for 125. We have 5 raised to the x equals 5 cubed. Now the bases are the same. We can drop them, and we see that x equals 3. So log base 5 of 125 equals 3. Number 14. We have log base 1/2 of 128, and we're trying to figure out what that value equals. So first we want to change it to an exponential equation. Remember, we're trying to figure out what is that exponent that we can raise 1/2 to so that we get 128. So our equation ends up looking like this once we change it to an exponential. We have 1/2 raised to the x power equals 128. We see that we can use 2 as the base, so we need to change the base on both sides so that they can be the same. We'll rewrite 1/2 as 2 raised to the negative first power. We'll rewrite 128 as 2 raised to the 7th power. It takes you a little bit of guesswork or just plugging things in to figure out what those bases and what those exponents are. Don't mind taking a few seconds just to go, okay, what's 2 raised to the 6? What's 2 raised to the 7? Oh, okay, I got 128. So go ahead and make the substitution. So now we have 2 raised to the negative x equals 2 raised to the 7th power. We have the same basis, so we can drop them. So we'll have negative x equals positive 7. So if we divide both sides by -1, we get x equals -7. So that means our exponent that we're looking for is -7. So log base 1/2 of 128 is equal to -7. Number 15, another situation where we're looking for that exponent. This time we have log base 10 of square root of 10 equals x. So we are going to change it to an exponential equation. We'll take our base, raise it to the x power. So 10 raised to the x power equals the square root of 10. We are going to use, oops, I have 2 here. We're actually going to use 10 as the base. Sorry. Using 10 as the base, we'll change the square root of 10 to 10 raised to the 1/2 power. So now we have the same bases on both sides. We can drop those bases and we'll get x equals 1/2. So the exponent that we're looking for is 1/2. 10 raised to the 1/2 power equals the square root of 10. Number 16. It says find the exact value of the logarithm without using the calculator. Once again, we have the square root of 3 as our base this time, but we're going to go through those same motions of changing it to an exponential equation, so we know we're solving for that exponent. So we'll have the square root of 3, which is our base, raised to the x power, and that is going to be equal to 81. We see that we can use a common base of 3. So we'll change the square root of 3 to 3 raised to the 1/2 power, and we'll change 81 to 3 raised to the 4th power. So now we'll have 3 raised to the 1/2 x, because we just multiplied those exponents together. We have 3 raised to the 1/2 x equals 3 raised to the 4th power. Now the bases are the same. We can get rid of them and finish solving it like a normal equation. We have 1/2 x equals 4. So we multiply both sides by 2 to get rid of this 1/2 over here to isolate the x. So we'll have x equals 8. So that means log base square root of 3 of 81 equals 8. So our exponent is 8. That's our answer. And we are moving on to number 17. For number 17, we see we're back to the natural logarithmic expression. So remember that when you have ln, that's the log of the natural number, which is log with the base being e. So we change it to an exponential equation. We have log base e of the 6th root of e equals x. So then we'll have e raised to the x equals the 6th root of e, which simply means if we change this radical to a exponential expression with a rational exponent, that will be e raised to the 1/6 power. So we'll have e raised to the x equals e raised to the 1/6 power, and then from there it's smooth sailing. We drop the bases, and then we will have x equals 1/6, and that is our exponent that we were looking for. Number 18 says find the domain of the function. We're back to those problems that we were looking at earlier, where we have to take the argument and have it set greater than 0, and it's not equal to, it's only greater than 0. So we take our argument, which is x plus 4. We have x plus 4 is greater than 0. We subtract 4 on both sides, so x must be greater than -4. Writing our answer in interval notation, we have the solution going from -4 to infinity with parentheses on both sides. Number 19, it says find the domain of the function. Once again, we don't care about anything else. The domain of our log functions come from where the argument is greater than 0. So we set our argument greater than 0 once again, and then we come up with an inequality that we can solve. We add 3 to both sides, and then we'll have x over 6 is greater than 3. In this case, we multiply by 6 on both sides to get x by itself. And our final answer is going to be x is greater than 18. So our answer in interval notation goes from 18 to positive infinity. Going back to Math Excel, now we have problems where we need to graph our log functions. And it says graph the following function and its inverse on the same Cartesian plane. So they actually give us both functions. So we don't need to do the work of finding the inverse. We can just graph it. So we see that the original function is an exponential function where 9 is the base. So we're going to start out with that. We're going to graph our exponential function, and we are going to set it up and make sure we change our base to 9. It doesn't have any further transformations. It's just 9 raised to the x power. So we're done with that one. And then now we need to graph our inverse function, which is log base 9 of x. So this time when we graph it, we're going to grab our logarithmic function, and we're going to put it on the graph. And this time, once again, our base is going to be 9. It has no further transformations. So here is our original function, 9 raised to the x. Here is our inverse, log base 9 of x. And we see it has that nice little property where it's symmetric about the line y equals x. You know, it's reflected across that, and we see that that's the picture that we're looking for, and we submit our answer.